If you know the roots of a quadratic equation, you can use those roots plus our understanding of the zero product property to create a quadratic equation to match those particular roots. So we're going to go through a few examples of the different kinds of roots that we might run into, and then how we can use those roots to effectively and efficiently write a quadratic equation that matches them. So in our first example, we're going to start with two roots that are rational numbers. We're going to start with -5/3 and 1/2. Now, if we know that those rational numbers are roots of a quadratic equation, and again, stress the fact that this is a quadratic equation, not the. There are an infinite number of quadratic equations that will have these two solutions. We know that based from the zero product property, that we would have potential factors of x plus 5/3 is equal to 0, or x minus 1/2 is equal to 0. We are guaranteed that by the zero product property. Now, in an effort to clean these up a little bit, we're going to multiply both sides of the left equation by 3, and we'll multiply both sides of the right equation by 2, clearing out some of the fractions and making these a little easier to look at. So we'll have 3x plus 5 equal to 0, and 2x minus 1 equal to 0. Now, the zero product property, if we're setting both of these equal to 0, guarantees that if we put them together in an effort to create the quadratic equation, that one of them would have to be 0. In this case, to finish finding our quadratic equation, we can simply multiply those two binomials together, and we get 6x squared plus 7x minus 5 equals 0. So again, because we started from a place we knew would create those two solutions, we rewrote those pieces based on a factor multiplication to clear out some of the fractions, and then we put those two pieces together into their own equation. We've created an equation that's guaranteed to have those roots. Just look at the page backwards if you need a little bit of assistance seeing what happened here. We would have normally have started with this equation. We would have factored it. We would have split into two separate problems. And then that's a little bit of a different cleanup than we're used to. Most of the time, we probably would have just stopped here and solved it. But it's essentially the process that we used for factoring, but in reverse. We're creating a factor that we know would need to be there, and then creating the equation from it. Modules and modules ago, we would have started here and gone backwards.